All right, so if you've ever worked with Sentinel-1 satellite data, you've probably hit this crossroads right at the very beginning. Should I download the SLC file or the GRD file? They sound super technical, I know, but trust me, by the end of this, you'll know exactly which one you need, and you'll know why. Let's dive in.
But first, before we get into the nitty-gritty, let's just step back and think about something that is kind of mind-blowing. How on Earth can a satellite, flying hundreds of kilometers above us, take a crystal-clear picture of the ground when it's completely covered in clouds? Or raining, or in the pitch black of night? It just shouldn't be possible, right?
Well, the secret isn't magic. It's this incredible technology called synthetic aperture radar, or SAR for short. You see, unlike a regular camera that needs light from the sun, a SAR satellite brings its own flashlight. It actively sends out a pulse of energy and then records the echo that bounces back. And that is exactly how this incredibly detailed map was made. It just sees right through the clouds.
Basically, SAR is a total game changer. By using the satellite's own forward motion, it cleverly pretends it has a massive antenna in space, which allows it to get these super high-resolution images. The key thing, the most important thing to remember, is that it makes its own light. So clouds, bad weather, nighttime, none of that matters.
Okay, so to really get a grip on what these SAR satellites like Sentinel-1 are telling us, we need to look at the signal they record. Every single one of those little echoes that comes back to the satellite has two fundamental pieces of information tucked away inside it. We call them amplitude and phase.
So what are they really? Well, amplitude is the easy one to get your head around. It's just the strength of the echo. A really strong, bright return probably means it hit something solid, like a building. A weak, dark return might be from a smooth surface, like a calm lake that's scattered the signal away. Phase, though, that's where things get really interesting. It measures the exact position of that returning wave in its up and down cycle. And this gives us unbelievably precise distance information. We're talking down to the millimeter.
Okay, so signal strength and super precise distance. How does any of this connect to those SLC and GRD files you see when you go to download the data? Well, this right here, this is the fork in the road. This is where those two different data types are born. So first up, let's talk about single look complex, or SLC. Think of this as the raw, untouched, foundational data. It's called complex for a reason. It keeps both the amplitude and that incredibly valuable phase information. With SLC, absolutely nothing from the original signal gets thrown away.
So why do we care so much about phase? What's the big deal? Well, this is where the really advanced science happens. By taking two SLC images from different days and comparing their phase information, scientists can measure tiny movements on the Earth's surface. It's a technique called INSAR, and it is just mind-bogglingly cool for tracking things like a volcano breathing before an eruption or a city slowly sinking. But here's the thing. If you just double-click on an SLC file, you're not going to see a pretty picture. It's complex data, full of noise and geometric distortions. It takes a whole lot of processing before you can really interpret it visually. For most mapping applications, we've got to turn it into something a lot more user-friendly.
And that journey from this raw, complex data into a clean image, well, it's a whole process. It kicks off with something called multi-looking. And this is the key step where that phase information is averaged out and discarded to reduce noise. Then you run through a bunch of corrections. You remove noise from the instrument itself, you calibrate the signal's brightness, you filter out that grainy speckle effect you always see in radar images, and finally, you use a topographic map to fix all the distortions caused by hills and valleys.
And voila! After all that hard work, what you're left with is our second product, Ground Range Detected, or GRD. Now this product only has the amplitude, just the signal strength. It's been all cleaned up, it's projected onto a map, and it's basically ready to drop into any GIS software as an image.
So, since GRD data is essentially a picture of how bright the ground is to radar, it is perfect for any time you need to actually see what's going on. Think about mapping out flooded areas after a hurricane, tracking where forests are being cut down, or even spotting ships out on the open ocean. If your goal is to map things you can see, GRD is what you want.
Which brings us right back to that big question. You're starting a new project, you're at the download page, you see SLC and GRD. Which one do you click?
Look, the choice really just boils down to this. If your job is to measure tiny, millimeter-scale movements on the ground using that INSAR technique, you absolutely must use SLC. You need the phase. But for almost everything else, if you're mapping land cover, finding floods, looking for ships, you want the GRD. The best analogy, and the one that makes it all click, is from photography.
SLC is like a photographer's RAW file. It has all the original sensor data for a technical expert. GRD is the finished JPEG, processed, easy to look at, and ready to share.
Let's just hammer this point home, because if you remember one thing from all of this, this should be it. SLC is the digital negative, the raw file. It's got everything, but it's for a specialist. GRD is the final photograph. It's been developed, it's been polished, and it's ready for anyone to see and understand.
So, the most important thing to get is that these aren't two totally separate things. Every single GRD image you've ever seen started its life as an SLC product. The entire process is about simplifying that data, focusing only on the signal's strength, the amplitude, and purposefully leaving that complex phase information behind.
Once you get this difference, you really unlock the full power of this amazing technology. From measuring the slow, silent creep of a landslide to mapping floods halfway across the world in near real time, SAR gives us this incredible new way to see our planet. And that kind of leaves us with a pretty fascinating question. As this powerful radar vision becomes easier and more accessible for everyone to use, what other hidden changes, what other secrets of our dynamic planet are we about to uncover next?